Hi friends, this is BHANUPRASAD. Today we discuss the topic is heat transfer by convection and radiation problems. Before going to the topic, please subscribe my YouTube channel. Convection problem. Determine the heat transfer by convection over a surface of 0.75 meter square. If the surface is at 200 degrees centigrade and the fluid is at 80 degrees centigrade, the value of convective heat transfer is 25 watt per meter square degree centigrade. So here we consider one hot plate. In this hot plate, one side hot fluid is travel above the surface. So now surface temperature 200 degrees centigrade, fluid temperature 80 degrees centigrade, area is 0.75 meter square and heat transfer coefficient is 25 watt per meter square degree centigrade. So first one is heat transfer by the hot plate. Now Q is equal to HA Ts minus Tf. Here H is the convective heat transfer coefficient and A is the area of hot plate, that is surface area, and Ts is surface temperature and Tf is fluid temperature. We can apply the values in this formula: 25 into 0.75 into 200 minus 80, and Q is equal to 25 into 0.75 into 120, and final answer is Q is equal to 2250 watts or 2.25 kilowatts. Radiation problem. A surface of area 3 meter square and at 200 degrees centigrade exchanges heat with another surface at 30 degrees centigrade by radiation. If the value of factor due to the geometric location and emissivity is 0.69, determine. First one is the rate of heat transfer, and second one is the value of thermal resistance, and third one is the equivalent convection coefficient. So first we observe in this problem in one heat exchanger. In this heat exchanger, area A is equal to 3 meter square. This is the surface area of the heat exchanger, and surface temperature Ts is equal to 200 degrees centigrade. We can convert in degree centigrade into kelvins, that is 200 plus 273, that is equal to 473 Kelvin. After that, the other surface, that is the radiation surface temperature 30 degrees centigrade. Here 30 degrees centigrade plus 273, that is equal to 303 Kelvin, and the emissivity or factor due to geometric location F is equal to 0.69. So first we can calculate the rate of heat transfer. So here the rate of heat transfer Q is equal to F sigma A T1 power 4 minus T2 power 4. Apply the values in this formula. F is equal to 0.69 and A sigma is equal to 5.67 into 10 power minus 8, and area 3, and T1 is equal to 473, T2 is equal to 303, and finally the heat transfer Q is equal to 4885.6 watts or 4.885 kilowatts. So this is the rate of heat transfer. Second one, thermal resistance RTH. Here RTH is equal to temperature difference by heat transfer, that is equal to T1 minus T2 by Q. So now substitute the values in this equation. T1 is equal to 473 and T2 is equal to 303, and previously we calculate the heat transfer Q is equal to 4885.6. So finally the RTH, thermal resistance RTH, is equal to 0.0348 degrees centigrade per watt. So finally the equivalent convection coefficient H. So H is equal to Q by A into T1 minus T2. So here this is the convection process. The Q is equal to HA delta T. So now small h is equal to Q by A into T1 minus T2. Now substitute the values in this equation. Previously we calculate Q is equal to 4885.6 and area 3 and T1 473 and T2 303 Kelvin. So we substitute and calculate the convection coefficient. H is equal to 9.58 watt per meter square degree centigrade. In this problem, the final answers are Q is equal to 4885.6 watts or 4.885 kilowatts, RTH is equal to 0.0348 degree centigrade per watt. H is equal to 9.58 watt per meter square degree centigrade. So friends, these are the convection and radiation problems examples. So anyone wants to these problems PDF files, please comment in comment section. I will provide you all PDF files. So please subscribe my channel and like me and share to others. Thank you very much.